Good morning, this is Mr. Pruitt, and I'm out again today, but today I'm going to talk to you about parallel circuits, or what happens when resistors are not lined up on the same path. So before we get started, we need to kind of review the river analogy for a minute, and you need to try to keep the river analogy in mind while we're working through these parallel circuits. So remember that the circuit itself is like the riverbed that the river flows down, and that the charges are like the water that's flowing through it, and that the current is how fast those charges are flowing, or what the rate of flow is. And that the resistors are like putting dams in there. It slows it down and keeps it from and it does work for us. And then you need to remember that the voltage, which is also electrical potential energy, is the difference in elevation from the source of the river to the mouth of the river. That it's what's causing it to flow. It's that difference is what causes the charge to flow through the circuit in the first place. Now, yesterday when we looked at series circuits, all of those light bulbs or resistors were all lined up on one path, like it had just one single riverbed to flow through, and it had to go through each one of those dams in series. Today when we look at a parallel circuit, what you need to think about it is it's like making a fork in the river, that the river gets split in two. And so when the river gets split in two, the current flows down on both sides of the split, and eventually when it comes back together, the amount of current that we started with before the split and the amount of current that we have after the split has to be the same, because there's the same amount of water that's coming down, or the same amount of charge that's coming down through each side of the split. And you can see that in that you can see where the split is, where the charge is by the little yellow arrows on the diagram. You can see where they split, and some of them go to the first resistor, and some of them continue on, and some of them go to the second resistor, and some of them continue on, and some of them go to the third resistor, and eventually, before they come back to the battery, they all meet back up again. So in this parallel circuit, what we do is we split our wire. The pathway gets split, and that causes the current to move through both or all three paths, and then again they come back together later in the circuit. Alright, so our rules for parallel circuits today. The first one is that when a resistor is switched off, if we put a switch in there and we switch it off, then the current stops being able to flow through that part of the circuit, which basically means that it's going to behave like there are fewer, the circuit will behave like there's fewer resistors. In fact, if you only have two branches and you switch one of them off, the other one's going to just act like a regular series circuit with one resistor in it until you switch it back on. Now, since the current split, the amount of current in each of the branches is less than the total current before the split. So, and that makes sense. If you think about the river, you have all of this water coming down. It splits off. Half of it goes to the left, half of it goes to the right. But the total amount of water is still the same. It's just that is just less of it in each side. And when the river comes back together, that amount of current or that amount of water is going to be the same as it was before. Also, the sum of the currents in each branch has to be equal to the total current, that goes back to that river analogy, that however much we had before the split, we have to get the same amount of it back out on the other end. It's just a part of the law of conservation of charge. Alright, and the last thing is that the voltage drop across the resistors in each branch should be equal to the voltage drop in every other branch. Okay, so you should get the same amount of voltage in each branch off of that split, and then that should be able to total back up to the total amount of voltage, whatever the voltage of your battery was whenever you put it back together. Alright, that's it for today. You need to make sure that you have logged on to Skyward and done the quiz. That will be over by 9 a.m. on Friday, and you need to pick up the second lab, the lab on parallel circuits, and do it today. Also, if you told the substitute yesterday that you needed a password for the FET, I'm a little bit upset with you right now, and you need to not try to pull that today and get both of the labs done today. Thank you. Have a good day. Bye.